Hey guys, welcome to Science Today. If you remember, yesterday we went over some potential and kinetic energy stuff. We looked at a ball rolling down a hill and we explored how its potential and kinetic energy changed depending on where it was on the hill. And so you're going to do some problems like that today. And so to help you along, I'm going to go through exactly what you need to do today. It's really kind of a review of yesterday, but we're just going to condense it down and get to the nuts and bolts. So here's the setup. A 4-kilogram ball is sitting at the top of a hill that is 5 meters. So this is kind of our picture over here. We got the ball, 4 kilograms, 5-meter hill. It's going to roll down the hill. We're going to explore what happens, right? So to get started, we are asked, what is its potential energy? What's its potential energy at the top of the hill? Now remember, we have some equations to help us figure some of this stuff out. So here's our equation for potential energy. It's the mass times g, which is the acceleration due to gravity, times the height, how high the ball is. So that's pretty easy. We'll just put that in. We've got potential energy equals m, mass, that's 4 in this case, times 9.81, that's g, always 9.81, times the height, in this case, 5. We're just going to multiply those together and we will have its potential energy. So I'm going to grab the calculator here. 4 times 9.81 times 5. Come out with 196.2. 196.2 joules. Or we measure energy in joules. Cool. The next question asks, what's its kinetic energy at the top of the hill? Well, remember, kinetic energy is the energy of motion, and right now, this ball is not moving. So it has 0 kinetic energy. There's no motion. It's not moving. So its kinetic energy at the top of the hill is just 0 joules. The next question says, what is its potential energy after it has rolled down the hill and reached the bottom? So, right, we're going to let this ball roll down the hill. And some of that potential energy is going to be turned into kinetic energy. And as it goes down the hill, it's going to have less and less height, which means less and less potential to keep getting faster. And eventually, when it gets to the bottom of the hill, there's no more height. There's 0 potential for it to get faster. It's going to be going as fast as it can go. And so once it reaches the bottom, there is no more potential. It's 0. Its potential energy at the bottom of the hill is just 0. So the next question, what is its kinetic energy after it has rolled down the hill and reached the bottom? So the idea here is that as the ball starts moving, then it gains kinetic energy, because remember, kinetic energy is the energy of motion. And so as this ball rolls down the hill, its potential gets changed into kinetic. And if you remember from yesterday, our discussion, we talked about how the total energy of the system stays the same. And so if we have a lot of potential and 0 kinetic, and as it rolls down the hill, its potential goes down as kinetic goes up. But remember, the total has to stay the same. And so in this case, once it gets down to the bottom of the hill, if its potential energy is 0, then its kinetic energy is going to have to be equal to its potential at the top, the total amount of energy it had when it started. So the kinetic energy at the bottom is just the same 196.2 joules. All of its potential energy has been converted into kinetic energy, the energy of motion. And then finally it says, what is its velocity at the bottom of the hill? This is probably the trickiest part of these problems. We are going to use our kinetic energy equation, but we're not actually going to be solving for the kinetic energy. We know the kinetic energy because of the ideas of conservation of energy, and the total energy in the system stays the same. So we were able to get kinetic energy that way. But what this does allow us to do is solve for the velocity which we are looking for. We don't know in this case. And so we're just going to set up that equation there using the kinetic energy we know, using the mass that we know, and then solving for the velocity. So here we go. We've got kinetic energy is 196.2, and that's equal to 1/2 m, that is 4, v squared. squared. All right, so we're trying to get v by itself. That means this stuff right here needs to go. But I'm going to do some stuff with that first. 1/2 times 4 is half of 4. 1/2 times 4 is 2. Save a little room, I'm going to go ahead and erase that instead of rewriting the whole thing. And just go with 2 right there. Again, remember we are trying to get v squared by itself. Actually, trying to get v by itself, so we got to get rid of this 2 and the square. We're going to work on that red 2 first. A number next to a letter means times, so to solve it you have to divide. I'm going to divide by 2. If I do it to one side, do it to the other. I'm just left with v squared over here. Sweet. Over here I have to do 196.2 divided by 2. Comes out to be 98.1. And finally, to get v by itself, I have to get rid of that square. So I'm going to take the square root, because square root is the opposite of square. They cancel each other out. So if I take the square root here, that cancels out. If you do it to one side, and do it to the other, and it looks like then v is going to be equal to the square root of 98.1. That comes out to be 9.90. V equals, let's stick with green here, 9.90 meters per second. Final answer. All right, so again, that's probably the hardest part of these kinds of problems is finding v. It's not too complicated. You multiply by 1/2, divide by that number, and then take the square root. That's all we really did, but it can look yucky. But I don't think you'll have any problems. The problems on your assignment that you have to do today look just like this. I'm just going to have you do the same thing. The first problem, I'm going to have you kind of go through all these steps here. The next problem, I'm just going to ask you about the velocity, which means you still need to go through these steps here to find that velocity. But it should be okay. Hopefully that was helpful, and good luck on the assignment.